Hi, welcome to this session in the Tetration video series where we're going to be looking at what exactly is Tetration. I'm Tim and I'm going to be joined by Remi in this particular session. So let's get started. Well, we can cover this particular topic again just very briefly. It takes about 19 minutes from the point that an attacker gets a foothold to a full-on breach inside a customer's data center. They are trying to deal with reacting within 19 minutes to a breach.
So you're saying 90 minutes, so by the time the bear gets through the entryway to the moment he's in the pantry, 90 minutes?
Yep. I don't think I could protect against that, no. Especially not in the middle of the night.
No.
So we're going to look exactly how Tetration is going to help you deal with reacting to threats within inside this 19-minute time range. And then once an attacker gets in, on average, they have around 100 days of free time to play inside a customer's data center.
Every time I see the slides, I get the smell, Tim. I'm sorry.
Yeah. It looks quite a lot like your dog as well, though, Remi. So.
Actually, that's why I get the smell.
Yeah. So let's go into exactly what Tetration is. Well, one of the things that we all have become to understand is that it's imperative to understand exactly what your data center, your applications are doing. You can read this quote. This is from the NSA, from Rob Joyce from the NSA. So if anybody knows anything about network security and breaching networks, I'm sure this gentleman knows a lot about it. And pretty much what he's saying is you need to understand exactly what is happening inside your environment before you can begin securing it.
I mean, that sounds fair when you think about it. You wouldn't fix something before looking into it, right?
Yeah.
And if you tell me your car is broken, and I'm not just going to come with a hammer and just go and fix it for you, right?
I really, really hope you wouldn't do that. I would expect you to go and do some diagnosis, go and inspect everything that's happening, do a full checklist of what's happening inside that engine before you start making any changes.
So you're saying that security basically is the same approach there?
Security has to begin with that same approach. You need visibility before you can begin to apply any controls. That's exactly what Tetration begins with. We begin with providing you as much visibility as possible. Not just visibility to your on-premises applications, but actually visibility to applications wherever they may be running. Tetration doesn't use an infrastructure-based approach, it uses an agent-based approach to get telemetry, which is pretty much just information about workloads across every single environment that a customer might have. We're talking public clouds and data center workloads. And when we're talking public clouds, we really mean any public cloud. We don't have a particular vendor that you have to go with.
When you say any, it means because obviously everyone that talks public cloud usually is like the three big ones. Nowadays, it's like, what if I use one of my, local cloud vendors, small company, 20 employees, but you know what, they have data locality. Can I work with them?
Absolutely. We don't want to impose any restrictions on their customer exactly how they should deploy their applications. That's not our business, and you shouldn't be changing the way that you deploy your applications or the choice of cloud for the security product that you're using. And that's why Tetration is completely agnostic to whatever cloud a customer might be using.
So cloud is sort of easy now because we've covered cloud,
Yep.
but I mean, there's also the data center, right? In data center, I mean, I have some like mainframes, I have some hypervisors, about 5 different hypervisors running in my environment. Everyone has their own requirements. I have containers, I have all the kind of fancy and bling bling stuff that you want in that environment. So maybe 3 to 5 sort of clouds here, like definitely tens, if not hundreds of different flavors here. Still works?
It still works, and in fact, it works better than you might expect. And the reason being is that we don't tie ourselves to any particular hypervisor, any particular workload type, whether it's a bare metal, a virtual machine, or a container. All of them are treated as first-class citizens to Tetration when it comes to getting that visibility. In fact, we have agents for all of those major different operating systems that you discussed as well. We have Linux, we have Windows, we even have some of those legacy operating systems like AIX, which were invented before my time, but I still believe that we need to secure them.
I think it's a good idea. We should secure you as well, by the way, but anyway.
So when you start with visibility, we send all that data to Tetration. Tetration in this case could either be delivered as an on-premises physical appliance, or you can purchase it as a software as a service subscription where you don't need to deploy anything. Sounds the easy way, right?
I mean, I'm thinking Happy Bear when you say that.
Yeah, I'm thinking Happy Bear if we go with the Tetration as a service option.
Yeah, that sounds
No
good.
hardware, no maintenance to deal with. You just deploy those agents and get all of that telemetry sent back over to us for analysis.
No orange making night. I like that.
Yes. So once we have that telemetry, what does that enable us to do? Well, we're going to go into a lot of depth about exactly what we can do, but at the end of the day, it provides you as a customer the ability to control those application workloads. That control might be applying east to west segmentation, or that control might be monitoring behavioral anomalies. Exactly whatever control you want to apply, you have that capability via Tetration using that distributed software agent.
That sounds pretty cool like that. So basically, back in the days, there was you can control what you can measure and just apply to security situation.
Pretty much in a nutshell.
That's pretty cool.
So let's go and take a little more of a look into exactly what type of data we collect, how we process that data, and then how we can use that data to apply those different controls.
Okay.
So the first thing we want to do is understand exactly what's out there and what normal looks like. But Remi, how do I really know what normal actually is?
That's what I was wondering, because I mean, normal looks very different depending on who you're looking at, right? I mean, normal for you is very different from normal from someone else. Very, very different.
Yeah, I'm sure you can tell that my normal is not very normal, but...
Exactly. Yeah. So I'm trying to understand what you define normal, and especially, I mean, things can go wrong. What if, I don't know, there's a malware in my normal? How do I handle that?
It's a good question. And what about if the application changes as well? Is that normal? Is that expected? These are all things that we've had to deal with customers over time, many times, right?
Yeah, definitely. So what you're saying basically is that we collect a whole bunch of data. That looks pretty nice, but I mean, usually when you collect network data, it doesn't look like that at first sight.
It doesn't look like that. And collecting that kind of data via taps or spans or places in the infrastructure, well, it's becoming harder and harder, right? And then how might you potentially, if you're not using a product like Tetration, how would you analyze that data?
It's a good question, because I'm guessing, I mean, now we're talking data center, right, for all what you're...
Well, here we're assuming that you have some way to collect that flow data, which is often possible in a data center, but outside the data center, not so much, right?
Well, I'm just wondering how you collect 400 gig per second today.
I don't think I can do that actually
I
without
think your laptop
spending.
can't.
Definitely not my laptop, and I'm not willing to spend the money to go and collect that 400 gig stream and process it using something that's a legacy tooling. And then even once I've got that flow data, doing spreadsheet analysis on it, trying to work out every single flow that's out there, is it unique, is it a legitimate flow? I don't want to be doing this. I'm going to be stuck in spreadsheet paralysis.
So first of all, that would be a real badass spreadsheet if you were to get there.
I think I'd run out of memory on my laptop.
That's the first thing. But so we're trying to get from a point where I see tuples of IPs, ports, protocols, and we kind of group them nicely, but I guess we do a bit more as well.
Yeah, well, the whole goal of Tetration really is to automate this entire workflow that you might have been trying to do manually via collecting this flow data, grouping it together, applying filters, and putting it into Excel. It's something that simply cannot be done by hand anymore.
Okay.
In fact, if we look here, human scale or machine scale.
Okay, so that's where the fantastic unicorn of machine learning comes into play, huh?
Oh, trust me, Remi, we're going to get to talk about machine learning all week.
Awesome.
But
now we have to see real machine learning, right? Because I mean, machine learning. I mean, I go to RSA. I go on the booth for RSAs. I think, is there even a single booth that doesn't mention machine learning?
You know, everyone talks about machine learning, but we're really going to show you how Tetration practically uses machine learning to provide you extra security controls.
That sounds good.
But the reality is here, human scale does not work anymore. 19 minutes again. There is no way that we can react to that at human scale. It has to be machine driven to react to those kind of time frames. So let's go and look at exactly how Tetration can begin to get visibility and apply controls at machine scale.
At this point, what I've pictured right now when you're saying that, you remember movie Matrix?
Yes.
Yeah, so basically you're saying Tetration is basically just sliding a whole bunch of graphics on a screen that I have to stare at? Is that the idea? Or?
You know, I always dreamed that I would be Neo one day, but unfortunately it's not going to be like that inside.
Shave.
Okay, I can never be Neo. But it's never going to be like that inside Tetration either. We want to be able to take that volume of data, take all of that data that would be impossible to deal with as a human, and present it in a way that you can actually take action on it in a user-friendly way.
Okay.
So it all begins with collecting this rich workload telemetry. We want to get flow data, process data, and the software that is installed on that workload. So we do that by deploying software agents, which we're going to have another video on later. And using that software agent, it is going to be looking at every packet that's going in and out of that workload. It's going to be correlating that to the processes that were connected to that particular socket. It's going to be working out what that process software version is, what package it came from, and is that potentially vulnerable? And we'll look into that later.
So I'm kind of confused now at this point. So are we talking DPI here? Deep packet inspection?
Absolutely not. We're not doing any deep packet inspection with Tetration. It is all based on header metadata. If you think about the modern data center, modern applications that are moving towards things like TLS 1.3, it's going to become impossible to decrypt that traffic anyway. Even if you could decrypt that traffic, being able to analyze what's inside the payload and work out what the application is, in many ways it seems like the backwards way to do that. Because we're on that workload and we have that process information, we can get a much more concrete identification of what that application is. And we don't have to deal with having a DPI engine. It also happens to mean if you are a customer in particular countries that have legislation, you're not having to deal with the fact that you're inspecting customer payloads.
That sounds pretty cool. But
yeah.
So when I'm looking at all that, so you're telling me that header, like, kind of important, but I kind of get a feeling that the way you're presenting it, process is more important. Or how does that fit in? Why is there three? Why do I need three?
So they're both as valuable as each other, but to get the complete picture, you really do need to have both sides of the conversation. If I just take flow data, I have no real way to identify what the application is. If I'm seeing lots of port 443 traffic on my network, how can I truly understand, was that Apache, was it Nginx, or was it some malware that was generating that traffic? To get that, I need to know the process. And the process is going to be able to help identify exactly who was generating that network traffic. But if I don't have network traffic, what can I do with that process apart from potentially flag it as being a piece of malware? I can actually correlate the flow data to the process to give much, much deeper visibility and identify what exactly is happening with higher accuracy.
Okay, I see. That sounds interesting. You have to show me how all this blends, though, because a bit.
Yes, we're definitely going to get into this. But one of the nicest things is this is very lightweight in terms of overhead. We're only going to be grabbing about 1% extra network bandwidth to get this telemetry to Tetration, and we're going to guarantee that that software agent uses less than 3% of the CPU on that workload to get that data.
Tim, you know me, you'll have to prove that, right?
I promise I will prove it later.
Okay.
I know you're very skeptical. So let's take a look at what we have next. So the first thing that we begin to do as that process data, as that flow data comes into Tetration, is identify exactly what the structure of your applications look like. Which workloads should be grouped together based on their similarities. And once we've done that grouping, exactly who they should be communicating with.
Okay, now the process information you were talking about starts to make more sense. So basically, flow data tells me that app is talking to fund management in your example, but that will tell me that inside app, it's, I don't know, Nginx that's talking into the fund management. Is that the idea?
That's the whole idea. If we look on this particular graph here, we'll see that web is using TCP 443, as is the app tier. If I didn't have that process visibility, I wouldn't be able to potentially identify that app is different from web based on the process information.
Okay, I see. But okay, why is that different than what you have today? Because right now, I mean, I can just go on two servers and just go in PS and go and see. So okay, why do I need that then?
So yes, maybe you might be able to do that on two servers. Scale that out to 100 servers, 1,000 servers, 50,000 servers across thousands of applications. Suddenly the problem becomes much harder when you look at it at scale.
I see. Okay, so the real problem we're trying to solve is, if I understood you kind of what you're saying, you want to automate that?
I want to automate this discovery. I don't want you as the end user to have to give me this information. I want Tetration to automatically discover this information and then keep it up to date as these applications change, all at scale.
But when you say discover, I mean, I heard lots of things around discovery. Do I need to provide this? Or is it discovering only the port? Is it discovering the grouping? I see group discovery. What does it do exactly?
Yeah, there's lots of different ways that you can use the term discovery. We think it really does need to have both parts of that equation to really be automated discovery. If you're providing me the grouping of the endpoints and all you're doing is working out the rules between, you're providing me some value, but really the hardest part for many customers is working out exactly which endpoints are needed to be grouped together based on their behavior. A lot of application developers just simply don't know that. Or maybe you might have an application that the developer doesn't even exist for anymore, or the team that built that application has moved on somewhere else. How, as an end user, are you going to be able to provide those groups? It's simply not possible.
I see, yeah. Okay, that sounds again interesting, but you have to prove it.
I promise, I'm going to prove all of this out to you.
Okay.
And so not only does Tetration discover the dependencies inside an application, all applications have dependencies on services. It's actually one of the things that we notice that customers most often get wrong when they're trying to move to microsegmentation is, what is my application actually dependent on? And Tetration is going to work out, my application, it requires DNS. It requires NTP. I need my users to be able to access it to the web tier over port 443. The entire picture of the application, both the intra-app and inter-app dependencies, are discovered automatically.
So all my shared services, all the infrastructure-related stuff, which usually is managed by another team, let's be honest. And okay, we can talk about busting silos as much as we want. I mean, again, unicorn.
Yeah.
But at this point, so you're saying that this tool would actually tell me what my actual servers workloads are talking to within the applications, group them and tell me, okay, those two servers are one part of an app, those two servers are another part of an app. And on top of that, tell me, hey, you know what? Those parts of the app are all communicating to DNS, to authentication and so on, which are outside my control.
That's exactly what it's going to do. Remember, to begin applying controls, you need complete visibility. And for a lot of organizations, getting this level of visibility is incredibly powerful for them.
I can imagine that. But then comes a question, just look at your diagram. Those ones, okay, I mean, those are servers. I'm guessing you can handle that. How do you know how users are actually accessing my applications? I mean, users can be, could be engineering, could be HR, could be finance, could be anyone. How do I know that?
So one of the interesting things is that often a lot of network and security products split themselves down the middle. I'm a data center product or I'm a campus product. We believe in Tetration that security needs to be end to end. And that's why we integrate with identity sources like AnyConnect, Active Directory, and ICE to be able to understand exactly what users are accessing those applications. I'll be able to say, hey, yep, it is Rob from engineering that is accessing this application, or it is Sandra from HR that is accessing the HR application, and we can use that to apply those security controls as well.
So that's pretty cool. So, but always be careful. Look, I have an iPhone, other people have Androids, agents?
No agents required on any of those end devices.
So you're saying that anything that's related in campus does not need a Tetration agent at all, integrates with whatever is running there today,
yes,
and feeds the data and gives me one single view?
It does exactly that.
That's, again, really cool.
Yeah.
But again, you'll prove it.
It's starting to sound cool, and we'll definitely get into some demos later where we'll be able to see how we can do this for real.
Okay.
So we discover the application policy, and we allow you to provide extra context around those workloads or those users so that you can begin to slice your data, analyze your data, control those workloads in a more human-friendly way.
Okay.
On the left-hand side there, you have the IP address of that workload. You might be able to remember one IPv4 address. Could you remember an IPv6 address?
Dead beef.
Maybe one of those.
Okay, I try. You can find some funny names, but yeah, okay, I agree with you.
We're talking about hundreds of thousands of workloads potentially in the future. There's no way that IPv6 addresses can be held in a person's head. Even IPv4, it's very hard. So what Tetration allows you to do is provide many different sources of context and metadata alongside those IPs so that you can say, for example, show me all of the workloads that are owned by Acme Finance. It's a much more human-friendly way to interact with the workloads that are inside your data center. And we're going to go into a very deep topic about how you can actually collect this metadata from lots of different sources. But you can see a couple of them on the side here, including Kubernetes, vCenter, and AWS.
So that's pretty cool. So wherever the data is, whoever owns this data can actually give me more data on it.
Exactly.
And then we'll talk about that in probably more details at some point. Okay.
We want to use those systems as a source of truth and pull all of that into one unified place in Tetration.
Pretty nice.
So alongside the context that we pull in from the external orchestrators and systems like that, we also help you define policy in a natural language way. We're going to discover those automated policies, but all organizations also happen to have policies that exist outside of the application. They might be regulatory policies, they might be blanket security policies, or they might be network-specific policies. You know, here we have an example where we're saying there's a regulatory policy that says untrusted may not access highly sensitive workloads. That's going to be merged, and we'll talk about that later, with the application-specific policies.
And so that's where you use those tags and notations you were talking about before. That's kind of the logic, right?
Yeah, the logic around this is to be able to use identity to build policies in a human-readable way and have Tetration work out exactly what needs to be controlled to fit those policies.
Okay.
So we take our natural language policy, and then we combine them together in a hierarchical fashion. So we take the intent of the business, we merge that with the policy of the application, the specific applications, and then we come up with a final set of whitelist rules that we can enforce on those application workloads.
So is that some form of sort of collaborative policies in which basically the guys who get slapped the harder have the highest priority?
It pretty much is trying to reduce that friction between the security group or the networking team and the application owners. Typically in the past, it's been a fight because of the fact that the application team has not been able to have autonomy. They've always had to rely on the security team to make changes, even if those changes are very basic changes, like allowing my web tier to talk to my app tier. What we believe and what we deliver through Tetration is the capability to democratize policy enforcement. You can give those application developers a certain sandbox that allows them to do some things, but also provides controls around that so that they cannot step outside the boundaries of that sandbox, including ensuring things like those regulatory policies are always enforced on every application, no matter what the app developer does.
So the goal is to say, okay, today, let's be honest, how do we open policies? Well, I open a ticket with an Excel spreadsheet, and they are going to ask me questions, and it's going to take some time, and I don't like doing that too often, so I'm going to give pretty large subnets.
Yeah, I remember the last time that we had to do that in our lab. We asked for a completely wide open subnet, right? Because we didn't want to go back.
So what you're telling me is that based on this model, you can give some form of blanket approval for some ports, which will stay closed until the owner actually decides to enable it?
Correct.
That's pretty cool. So it means I don't need to wait for answer from every time?
Exactly. I can pre-approve some ports, and I can also pre-deny some other combinations as well. So I can say, for example, if you're holding PCI compliant data, you may never access the internet, for example. So I have both sides of the coin, and as an administrator, I can apply those consistently across my workloads.
Pretty cool.
Yeah. So exactly how do we go and apply those controls? We've got visibility, we've worked out what the applications look like. We actually need to go and say, lock that down and stop anything happening that's outside of the boundaries of what we've learned. And the way we do that is by automating policy enforcement via the software agent. So the agent that runs on every single workload actually receives an optimized set of policies for that workload, and it programs those into the native host firewall. So on Linux, we're talking about IP tables and IP set, and on Windows, we're talking about the Windows Advanced Firewall.
Okay, so no kernel module, nothing fancy to deploy. Do I need to reboot?
No reboots needed, no kernel module required. It's a hit list installation, and it's going to be able to let you have that security policy pushed out as close as possible to the application itself.
Very nice.
Yeah. It achieves a very scalable way to enforce these east-to-west segmentation policies, and it's totally infrastructure agnostic. I'm not going to ask you to use a particular switch. You don't have to use a particular hypervisor. You don't need to use a particular cloud vendor to get any of these policy enforcement controls applied. In fact, that's the complete beauty of it. When you have Tetration application segmentation enabled, you have enforcement across your on-premises workloads, your cloud workloads, whether they're bare metals, virtual machines, or containers. The same consistent set of policies applied everywhere.
So, in short, if I go back to Lord of the Rings, you're giving me the ring.
I'm going to give you the one ring to rule them all, absolutely.
I like that.
Yeah, and you have to deal with that power appropriately.
Absolutely, that's Spider-Man now.
So, we can apply segmentation, and we can even extend that segmentation to those campus users, as we were talking about earlier. We can use information like SGTs or authenticated status to exactly control who can access particular applications.
Okay, that's pretty nice. SGT, I guess you mean the group tags?
The security group tags.
So
yes.
that's a campus native construct that
Yes.
we're actually extending inside the DC, should you wish to do so.
Exactly. A lot of campus admins have already gone to the trouble to create SGTs, security group tags. Why should we blast that away and ask for something else when we could just simply extend that into the data center?
Nice.
Yeah. This is very, very powerful, and it really helps customers answer that particular problem around the dissolving perimeter and the need for end users to bring their own devices and be accessing applications from anywhere in the world.
So is that sort of kind of going towards the Beyond Corp, the Zero Trust kind of framework and stuff like that slowly?
It is, absolutely. Tetration is a major pillar of Cisco's Zero Trust framework. It fills the workload segment of that particular framework.
Pretty nice.
So we have segmentation enabled. The next thing that we really need to be able to help customers doing is reducing that attack surface, working out what should be locked down.
So that was putting the honey in the pantry, right, and closing the door?
Exactly.
I see.
So what we do to achieve this is we take that telemetry from the workloads and we feed it into our system to be able to, number one, detect known vulnerabilities. This is a really, really simple one, but it's actually incredibly effective. Are you running out-of-date software that has known vulnerabilities? The answer for most customers probably, unfortunately, is no, but the reality is yes.
Okay.
So, for example, Apache Struts, this was the one that the credit bureau had to deal with. That CVE was very well known ahead of time. If they had actually gone ahead and patched it, they would have not been breached. So what Tetration will do is firstly give you visibility into the fact that you have those known vulnerabilities.
You just mentioned something that's always interesting. Struts and things like that library is right. So, patching is not as easy as just like APT update or whatever. And you can do that, right? So, can I do anything else in that? Because telling me the vulnerabilities there is great, but now what?
That's true. So we'll talk about this in a later session, and we'll show how we can use Tetration to wrap controls around those potentially vulnerable workloads. You're right, not every business can patch overnight, but we can potentially do things such as applying quarantines to that workload that allows it to access the dependencies it needs, but it might not be able to access some higher privileged workloads or some customer-specific data. You can find a middle ground between instantly patching, but also not completely taking it off the network.
So we're doing some form of virtual patching. I'm not a big fan of the term, but that's sort of the idea.
Yes, exactly.
Okay.
So then we also take the hash of a process, and we take the hash of that process to be able to work out, well, are you just running a known piece of malware? It's very easy to take the hash of a process and look it up against a threat intelligence feed, and that's what Tetration does. It's certainly not guaranteed to provide complete security. It's not a silver bullet. It is definitely not going to find every bit of malware on your environment, but it's going to help you identify, are there some basic sanity things that I need to do? Is this a clear piece of malware that shouldn't be running on my network?
So now it sort of kind of tightens the balls between different stuff. So when you were talking about the flow and the IP addresses, as you can link this flow to a process, if the process, you can check the hash as per what you're saying here. What you're actually saying is that if I was to look at the norm of my environment, I can actually flag that norm with thread feed data to say, you know what, actually this norm is abnormal.
Exactly. It helps customers answer that problem where they're saying, did I just bake something into my policy that is actually abnormal?
I see.
And then finally, we can actually reduce that attack surface by closing down those ports and not allowing them to be open.
Like the famous NTP port.
Like the famous NTP ports.
NTP, which is open everywhere, that no one ever configures.
Everyone has it configured, but they never use it.
I see.
So we can move on from hardening the attack surface, which we can apply controls using Tetration. And that's going to help you lock down and potentially avoid some vulnerabilities on those workloads and help you detect if there is a bad known state for that policy. So we're going to look at the workloads, look at those vulnerabilities, help you put policies in place that might protect you against those known vulnerabilities.
So that's the sort of virtual patching, right?
This is that virtual patching where you're able to say, take any workload that has Apache struts, find out exactly what those workloads are, and then apply a block that will say you're not allowed to generate outbound network communication. You can still receive inbound network communication. You can still act as your typical web server, but you're not, if someone were to breach that workload, they couldn't start reaching out to the internet.
I guess thanks to the statefulness of the connection, that's how we...
Exactly.
Okay. That's pretty nice.
Here we can see where we've detected a vulnerable version of system D, in this case, where someone's replaced a binary with an anomalous binary. And we're also able to reduce that attack surface by understanding how many ports are open on workloads that should actually be closed. Here we can see all of these ports that should actually be closed.
NTP.
NTP, prime offender.
I see IPv6 as well in that list.
Yes, you can see IPv6 here because we're not only protecting IPv4 interfaces, but we're fully supporting IPv6 interfaces for policy enforcement as well.
That's an interesting one. So you're saying that, for typical example, SSH and link local. So those ones usually we tend to forget to firewall them.
Yep.
So that would show me that even though if I'm using SSH on the other IPs, if I see SSH, if there's no connection on link local, it will show up here.
Yes.
Very nice.
Yep. Really going to help you lock down those accidental things that you might not even be aware of.
Exactly. Easy to forget those things.
Very, very easy to forget, unfortunately. So once we've been able to reduce that attack surface, the final piece of the puzzle is being able to identify behavioral anomalies. So it might be that we've reduced the attack surface, we've enabled segmentation, but unfortunately an application vulnerability comes out and someone manages to get access to your workload, to your network. And what you want to be able to do is see exactly what happened in a short period of time and react to that. So via our forensic engine, we're going to be able to see things like a vulnerability being exploited, the attacker getting privilege escalation, delivering that payload and getting a foothold into the network. This is going to show us within 1 minute that someone might be inside our environment.
Maybe I should have brought some popcorn. What's that play sign there?
So it really is almost like a DVR in that you can play back and forth the exact structure of that particular breach. You can see the timing, you can see what process was launched after the other, and again, you can even use that for compliance. If you need to prove to your boss, okay, we were breached, but this is exactly what happened. These are the commands they executed, these are the files they accessed, this is the data they sent out of that workload. Using this slider back and forth, you can see this.
Very cool.
And we have another example here where we're showing a step-by-step of that slider. So we can see that they prepare to execute, and then they get command and control of that workload, and then they're persisting themselves onto that device. So we can not only see that we were breached, but we can see that this device itself needs to be completely destroyed because they actually managed to persist their exploit.
Next time I bring popcorn, I promise.
Yes, watching one of these playback really is popcorn worthy sometimes.
Really nice. And all this is recorded on the system? Like, where does it record? Because obviously, like, the guy has, obviously he spawned my machine at this point, so...
Yes.
Where does it go?
So all of this data is sent up to the central Tetration appliance, and that means that even if that machine is owned, that's not going to affect our recording of that data. It's going to be there on our central system, you're going to have it for months worth of time, and even if you weren't aware of the breach at the time, you'll be able to go back inside the Tetration cluster, apply a filter to search for these particular events, and replay them step by step in case you need to prove some sort of compliance later on down the line.
Okay.
Okay.
So far, it looks nice.
It does. And so really, that kind of concludes the end of our session. Hopefully, the bear is not looking quite so threatening now. Looks like it might even be a little bit cuddly, and that you can really get on top of this particular problem.
I'd definitely go and have a nap with the bear, that's fine.
Yes, once you've applied all of those controls, you really can rest easy or easier at night. So with that, thank you for joining us in this session. If you would like any more information on Tetration, please go to cisco.com/go/Tetration.